I have to admit, I've had a lot of fun here the last couple of days. I've had the opportunity to participate in the spring school. As was mentioned, we've got 18 students, half of them from Germany and half of them from other parts of the world. And it's been a lot of fun. I find it a lot of fun when I get to deal with systems engineering students, folks that are working on their PhDs, bright, intelligent, trying to figure out how do we further the practice of system engineering. One thing I will mention to you is that Stevens Institute has been working in cooperation with the System Engineering Research Center in the US to develop a reference curriculum for systems engineering. And we've worked with a lot of companies, a lot of schools, and I'm not sure if that's been published yet or not, but that is something that I will try to get to you, even in draft form. I think that would be of a lot of interest here. What we're trying to do is standardize, because we found the same thing, that there's a lot of inconsistencies across the different universities in teaching systems engineering. And so we've worked with them to try to say, okay, when you have a student that graduates with a master's degree in systems engineering, what are the expectations that that student knows? So I think that that will be a large contribution to the entire systems engineering community when it's published. If it may have already been, I have to go back and look at that. That aside, I have to admit, I'm a little intimidated. I don't like standing behind podiums. I thought the podium wasn't in existence that can contain me. There is, because the microphones are here instead of a lavalier. So I will put on my eyeballs. Now this is interesting. I'm not seeing this presentation here.
Problem 2.
Perfect. Now it's in the, okay. So what I want to talk about is patterns in systems engineering. How can we use them? Because I'll tell you right now, they're not being used. The software community has adopted the notion of patterns. You have those that understand patterns and use them. You have other software folks that don't. So when I started looking at this and saying, how can I improve the process of system architecting? Patterns was one of those that I found that exist in civil architecting. I looked at civil architecting quite a bit for how do I improve the process of systems architecting. So I like to start off normally with a quote. I read a lot. I love Louis L'Amour. I grew up in Southern California. In 1905, we still had people riding horses and having shootouts. You know, those old cowboys, as only 100 years ago. Not nearly as sophisticated as we were over here in Europe. But Louis L'Amour, in one of his books, he talked about how the human eye has a readiness for patterns. We see it even though we don't know it's there. And the example he used was that straight lines. Straight lines don't occur in nature, but our eye can pick it up very quickly when we see a straight line. So I found it very interesting that even a novelist understands the importance of patterns. If you go back centuries ago, I found that there's this, when you look at the cave paintings, whether they're in France, whether throughout the US, you find that there are patterns in the way that people were drawn. You can look at almost any kind of cave dwelling where there is a person represented and you find patterns. So it's not a new notion, it's not a new concept. I was in New Mexico a few years ago and I found a poster that talked about and showed some of the different cave painting representations or patterns of like a snake or a bird. And so there have been patterns used. Sometimes we call patterns habits, don't we? We pick out habits. Kids are brutal. They pick out bad habits of other kids and they kid them about it, they tease them about it. So patterns are something that are natural to people. It's just as engineers, we seem to think that they stifle our creativity and we hesitate to use them. So let me fast forward. The Complexity Institute, the Santa Fe Institute, there's been a number of books that start talking about the golden pattern, the golden ratio, and we see that some of these patterns continue to occur in nature the more we look for them. If I fast forward many years and look at Thomas Edison, he used to look for patterns. He would look at something and say, where have I seen this before? The phonograph needle came to him as an idea from the teletype, from the telegraph. So he said, okay, how could I use that in other applications? So we begin to see into modern day some of our great minds, some of our great thinkers start addressing the notion of patterns and reusability. Sometimes we call it modularity, but I'm going to address it more from a patterns perspective. Where the modern day pattern concepts really started is with a gentleman named Christopher Alexander. He was a civil architect at Berkeley. He was a mathematician by training. Why does this continue to flip? Well, I guess it doesn't. And in 1964, he actually wrote a book called The Synthesis of Form. Later on, there were some software guys that were listening to a presentation that he gave in a forum at Berkeley, much like this forum. And he was talking about patterns in civil architecture. He'd done some research as he did his designs, as he did his architecting. He found, for instance, that a family that is just starting out, a young couple, they preferred flats that had a place for one spouse at one end of the flat, the other spouse at the other end of the flat. And their common area, their family area, was somewhere in the middle. As that couple got older and they had kids, and those of us that have kids, they want the kids at one end of the flat and the adults at the other end. Now we know that doesn't work because the kids end up everywhere. Bill Cosby said, parents aren't interested in justice, they're interested in quiet. Let's put the kids at the other end of the house. So those desires began to change, but he would actually test these concepts and these principles as he would show individuals or couples different types of flats. Another one, very common one, is he called it light from two different directions. If you enter a room, much like this, people prefer a room that has lighting coming from two different directions, as opposed to light coming from one direction. They feel warmer in there. So he really began to confirm the notion of patterns within the civil architecture. You can buy pattern books about patterns. Well, in 1987, as I mentioned, these two gentlemen, Ward Cunningham and Kent Beck, were studying software engineering, software programming at Berkeley, and they heard them talk about this. They said, you know, this is interesting. We reuse a lot of code in Smalltalk, one of the early object-oriented languages. And says, can we do the same kind of thing? Can we take that piece of code and abstract it in such a way that it's reusable in other applications? And so they wrote this paper, presented it at the object-oriented programming conference in Orlando, and that really became the birth of the software engineering patterns community, a very large patterns community. In 1995, four gentlemen from IBM published a book, Design Patterns. Any software person that is using patterns, you will probably find this book on their desk in their private library somewhere. As I mentioned, you can, if you start looking around, you start finding that there are patterns books for architecture, for software. In fact, there are a number of architects that actually apply Christopher Alexander's principles also. Here was an example of one architect for Sunlight Homes that said, hey, here are some patterns that I use, and we actually implement these because they're, in a way, you could think of patterns as best practices. Okay. Here is the example of the light from two different directions. We find that people just prefer that kind of a room because it provides a warmer environment. If that's a pattern that works, if that is something that people prefer, wouldn't I as an architect, wouldn't I as a builder, try to design as many of the rooms in a new home, in a model home, with light coming from multiple directions? It would make my homes more popular. In fact, those that do that, I've been to a number of homes where the architect did just that. So, as I look at this, I find that there are a number of drivers, many of the same drivers that you talked about, that you found in your research, in your survey, Roman, that there are reasons we want to use patterns. We're looking for some way to capture that corporate knowledge that we have. I see some of the audience have gray beards like I do. And we're getting to that age that we're going to walk out of industry. We're going to retire. We're going to play golf instead of work. But yet we've accumulated many, many years of experience. And when you are a project lead or the lead system engineer on a project, you say, you know, I know we shouldn't do that because I tried that 10 years ago and it didn't work. Okay, we have this implicit knowledge that has never been documented. There's a lot of that knowledge that's going to go away in the near future. The systems are much more complex. We need to find ways to leverage patterns to work on the common parts of a system so that we have more time and more funds available for those advanced parts. Transmit-receive unit in a radar. If a company's already got 10 or 12 of those on the shelf, why don't we figure out a way to reuse that transmit-receive module and put our research into the material science of trying to figure out how do we come up with a more efficient transmitter face, for instance. So there's a number of drivers. I'm not going to go through all of them. They will be in the presentation. So I really have come up with 4 key reasons why I care about patterns as a system architect. The first one is the knowledge management, as I just said. If I can capture that knowledge in a more abstract manner that is reusable over and over again. I had a meeting just before this presentation with the Consents people, and they're actually working here in Paderborn to capture patterns and are beginning to do some work there. And I thought they had some excellent work there. They're trying to capture the knowledge that has been harvested from previous successful projects so that it can be abstracted and used again in other ways. Controlling complexity. If I'm not solving it, I'm not making it easier, but at least if I've had this pattern, have seen this pattern in other places, and I apply it in my system, I at least understand the bounds of the complexity of that pattern. I may have other places that my complexity will emerge. I know what I'm using in that application. My common understanding. It's interesting, when they first started talking about, when the software people first started talking about a layers pattern for an architecture, that would show up in conferences, it would show up in journal papers. Today, I would venture anyone that is a system architect, a software architect, maybe even a mechanical architect, understands the notion of layers and how you layer your architecture. Because that's become part of our common vernacular, part of our common language. If you talk about a client-server architecture, most of us know what that means today. In mid-90s, they didn't, but it was identified and documented as a pattern. And people started talking about it, and so it developed this common lexicon across engineers. It's another value of patterns. When they are published, when they are reused, more and more people know about them and understand how to apply them. And the last one that I list as a value is mitigating risks. It doesn't resolve the risk, but again, because you know what the risks are with that pattern, because some of those risks hopefully have been documented as part of the pattern documentation, you actually know what those expectations are. Someone has already helped you by documenting those previous implementations of the pattern, and they should be getting documented as part of the pattern. So these are, to me, and as part of my research, I've boiled it down to 4 key values of using patterns. So I have a lot of questions off and on that say, okay, well, where do patterns fit in conjunction with best practices, with processes, etc.? And so I've tried to come up with a simple 2x2 matrix that says my best practices are least documented, least published, because most companies don't want to tell you. Lockheed does not want to tell Raytheon what Lockheed's best practices are. They see those best practices as a competitive advantage, so they're not made nearly as publicly known. They're probably not documented very well either. They're part of that implicit knowledge that those systems engineers have. I think patterns then tend to be more formally documented, hopefully become more published, although I'm finding they fall into the category of knowledge that companies don't want to share. If they are doing anything with patterns, I've found it very difficult to get companies to allow me to document and publish their patterns. And then there's processes, which are high degree of formality, much more focused to a specific enterprise. So I just tried to help people understand where patterns fit with some of these other things that we are much more familiar with as engineers. The key issue with patterns is abstraction. This is one of the things that systems engineers tend to excel at. My wife calls systems engineering an oxymoron. What I mean by an oxymoron, if you're not familiar with that term, is when you put 2 words together that you wouldn't really ever do, but they actually have some meaning or don't. So for instance, military intelligence. You wouldn't normally put those 2 words together, and yet they have a meaning, right? So when you deal with systems engineering, a lot of times the system engineering job is to try to abstract the problem. What is my logical architecture instead of a physical implementation? Well, the same thing is true with patterns. I had the opportunity to visit the Georgia O'Keeffe Museum in New Mexico. And Georgia O'Keeffe is a very famous woman painter. She does her painting, did her painting, she's not with us anymore, in a very abstract nature. When I was there, they actually also had photographs taken by Ansel Adams, another very famous person in the US, but a photographer. And it had pictures of the rose side by side, a painting by Georgia O'Keeffe and a photograph of a rose by Ansel Adams. And they had a quote from Georgia Adams, where Georgia O'Keeffe, where she said, "I know I can't paint a flower on the desert on a bright summer, but maybe in terms of paint color, I can convey to you my experience." I think in a lot of ways, that captures what I try to do with patterns, what people that do patterns or try to document patterns also. They're trying to capture the essence of the architecture without specifying all the detail, so that you can recognize where else might I use this pattern without having to have all of the answers, because all the answers may not apply, may cause you to then decide, oh, I don't want to use that here, okay? I've already talked about implicit and explicit knowledge patterns. If you document your patterns, that implicit knowledge becomes explicit. So I want to get to some actual examples, so let me just jump over that. A lot of times when you do patterns, you have to take a black box approach. You have to treat that system, that part of the system, as your system of interest and say, where are my external interfaces? What is it that has to come into my pattern? What is it that I want out? and then let the designers figure out how they implement the internals of that subsystem or that system. The other important issue that I'll talk about, and then I'll give you a couple of examples of patterns, how you might use them within systems engineering, is the notion that you don't decide, you know what, I'm going to go invent a pattern today. I'm going to sit down and write a pattern. The whole patterns community has been about where have we seen this before. In fact, they have a pattern called 3 or more instances. The pattern on pattern says, I have to have found this in 3 or more successful instances before I can document it as a pattern, before I can call it as a pattern. Now, maybe within systems engineering and big systems, airplanes, things like that, maybe we're going to have a little more problems finding 3 instances. Maybe we have to modify that to maybe a couple. If I find it used in 2 different instances, maybe we can call it a pattern at that point. I'll show you something later that I actually did find a very large system that I could abstract as a pattern. So here's an example that I found done in the early 2000s. He was writing or creating a piece of software, custom software, to manage a small private bookstore in the UK. This is an old diagram type that really isn't used very much anymore, data flow diagrams, but it still will convey the issue. So on the left is the top level function of that software was to fill a book order. When you said, okay, great, fill a book order, here's all my actors, here's my repositories, here's the data. I need to know customer data, I have to know what's on my bookshelf, I have to be able to do back orders if I don't have it, I've got to have the books, and I've got to invoice my customer. If you look then at the next level of decomposition, say, okay, in order to fill a book order, I have to check the customer's credit, I have to be able to order books, I have to be able to calculate the charges, I've got to supply the book, I've got to create a back order if I don't have it. So that's the next level as you start thinking, okay, how do I break this down? So that was the example that they gave, and they came up with their software design based on that. So all I've done on this slide is taken what was on the right, now I've moved it onto the left. So this is the same picture here that I had on the previous slide, that decomposition. And then I say, okay, what if instead I want to modify this same architecture, but instead of selling a book, I want to sell a service. I begin to make changes essentially everywhere the word book appeared. I can change it to service. And I can almost get to the exact same architecture. I don't have to go re-architect my software. I have to make some minor changes, and now I can use it to sell a service. So if I say, okay, can I then take that and make it even more generic and talk about, well, I could do this for any kind of a product. So let me replace the word book or replace the word service with the word product. I probably at this time now have a fairly generic pattern that has a data flow diagram that can be modified for almost any kind of product or service that I might sell. We're in a university right now. What if instead I want to use it to design some software for course registration within a university? I go through, I change the word product to registration, I change the words customer to student, I kind of delete, there's some parts that I'm not going to use. I'm not going to talk about back ordering a course, so I'll delete that part of the pattern and make sure I delete any ties to it. And now I essentially have a logical architecture for a piece of software for course registrations, derived from a pattern that started out as an instance to sell books in a small private bookstore. So that's an idea of how I would use patterns. Let me skip a couple slides here. When I get to the point where I talk about system architecture then, if I have to put together a definition of a system architecting pattern, I will say that it essentially constitutes a high-level structure that I can use for the design of major systems or subsystems that might be used in other enterprises that have come from time-proven instances of problem solving that are similar in nature. Okay? Yeah, I cut out some of the words, the full definition is there. But that's the idea of what I'm trying to accomplish. About now, you might be thinking, well, gee, Rob, how's this different from a heuristic? How's this different from a template? How's this different from processes? So I've gone out, thought about that. Heuristics, really, a heuristic is a rule of thumb, right? It sometimes works, but not all the time. Murphy's Law. If anything can go wrong, it will. We use that as an excuse when something goes wrong. But usually things don't go wrong. But yet, Murphy's Law is a good example of a heuristic. In the real estate business, they say real estate's all about location, location, location. That's a heuristic. Sometimes location doesn't matter. But it's a rule of thumb that if you're thinking about real estate development, you take that into account. So patterns have much more information in them and are much more reliable than a heuristic. A template typically says, I need this kind of data, but it doesn't give you any information. The example I just walked through certainly gives you a lot of information. It's not just a blank form that you fill it out. Now, I understand for mechanical engineers, a template means, it's really, template for a mechanical engineer does mean a pattern. So there's even differences in our lexicon across the multiple domains. I talked about that. So let's look at some simple patterns that are out there. Very briefly, some I've just thrown together. They're probably of limited use because they're probably common knowledge already. But you could think about a telephone system, which has got, all phones have got some kind of a speaker, they've got some kind of microphone, they've got some way to dial, they've got some communication unit. Whether I'm talking about a cellular phone, whether I'm talking about a desk phone, whether I'm talking about a satellite phone. These are common parts of a phone. I could abstract that up. If I wanted to talk about, at a broader level, I can begin then to talk about how are those pieces connected together, so I can begin to build a model. And then, of course, you start having a physical description of it. While each one of these are produced by different suppliers, they have a common look and feel to them. We all recognize them as smartphones. You look at a weir. A weir is an ancient device. It's a way to deflect the flow of water from around pylons of a bridge. Also happens to look like a leading edge of an aircraft wing. It also, what I have found, is that now there are companies, BAE specifically, some others, that have actually decided to use a weir pattern as a way to design the undercarriage of a vehicle to deflect a blast. So it's a pattern that is used and in fact, I was at BAE at one time in a model-based systems engineering workshop where I was asked to talk about patterns, and then I broke them into groups and asked them to identify what kind, some of the patterns that they might use and don't realize are patterns, and this was one of them that they actually shared with me. A lot of others start showing up. Hubs and nodes, whether you're talking about the internet, whether you're talking about communications networks, whether you're talking about airlines, Federal Express. Let me go into a real detailed one. This is a perform command and control, perform C2. I was actually able to, I found a system that use this. So this is an IDEF diagram, if you're not familiar with it. It's a diagram that system engineers have used for 15, 20 years. Computer scientists used to use this. It was developed by the Air Force. All of your inputs always come in from the left. Your outputs always go out to the right. Your enablers come in from the bottom, and your controls and constraints come in from the top. So I found a command and control system that they actually had used this notation to document how they were going to do command and control. I thought, wow, this is really good. If I had a junior systems engineer and had an assignment that we had to go develop a new command and control system, whether it was for the military, whether it was for a police department, a fire department, one of the things we learned in New York City with the bombing of the World Trade Centers, the command and control centers of the police and the fire couldn't communicate with one another. So they took an initiative to say, how do we improve that command and control system? If instead of taking my senior systems engineer, my senior architect, that has developed command and control systems, what if I took a mid-grade, said, okay, I'm going to mentor you, and I want you to start your logical architecture using this pattern for command and control. There's a lot of knowledge at this level. It's telling that new architect or that mid-grade architect what kinds of questions to ask. What kinds of disciplines do they need to go talk to? However, as I started looking around, I found that I could find the next level of decomposition for that. And I found that they had used the plan, detect, control, and act. And it had all of the interfaces between each of those submodules or subsystems or whatever you want, whatever your nomenclature is. If I gave this to a mid-grade architect and said, start with this pattern, you think that that person now has a huge leg up, has a huge head start on developing an architecture for a new command and control system? They can decide which of these they need to use, which ones of they don't need to use. And in fact, I was able to identify 4 total systems that had used IDEF and had used the plan, detect, control, engage, or act paradigm, and was able then to mine out the generic parts of that, create this pattern, so that now it's not specific to any domain at all, and say, this can be used for any command and control problem that you want to solve. I will save a ton of time and effort starting here. I don't have instead of starting with a blank sheet of paper. I was hoping it wasn't double-sided, but you're efficient, it's double-sided. I was going to hold up a blank sheet of paper. By the way, Roman mentioned that. He said a lot of times our architectures are paintings. They're sketches. They're done in PowerPoint or PowerPoint on steroids, Visio. Okay? They're not done in modeling languages. These are modeling languages. So I would actually also, there's another notion within the patterns community called a pattern language. If you see here, you've got a plan, detect, control, and act, or engage. I could argue that the plan part of that is a pattern in and of itself. I could have used the inputs and outputs and constraints and enablers for this pattern to plan today's event. It might have been overkill. It may have been more than I needed. But you could begin to think of the collection of some of these subparts as patterns of their own, and patterns that interact with one another, which is another, Christopher Alexander, one of his books was a pattern language. And he has like 127 different individual architectural patterns for buildings and landscape and communities that interact nicely with one another. Here's a practical example. There was a civil architect in New Mexico that kept having to add new power substations. as some of the communities expanded around Albuquerque, around Santa Fe. So what he did is he created a pattern that said, okay, here's my control station, and then here is a module for each of the power grids I want to add, depending on how much new power I need. So something that used to take, here's an example then. It used to take 12 to 18 months to get a new substation architected and approved. He reduced that by getting these approvals of the pattern, said, okay, every time we have to do this, they will have already seen the pattern, and I'll just add the number of grid modules. He brought that 12 to 18 months down to 58 days. From the time the need was identified to the time it was up and running. Reduced the time from 18 months to 58 days. Again, consistent with our shorter development life cycles, our need to respond faster. Patterns will be one of those ways, I believe, to help us get there. We need a way to document it. I'm not going to spend a lot of time on this, but the diagram in and of itself is not enough. You have to talk about what is the pattern, because you've got to be able to find these things. If you publish them, what's the pattern name, what's the application of it, what are the interfaces, etc. So the way that I document patterns now is I use a template, a pattern form is what the community calls it, fill that out, and then I would include the additional diagrams, models, sketches, whatever I need as part of that pattern, so that it's been documented so other people can use it. There's a couple of challenges that I've seen in the last few years about patterns. Mining patterns is difficult in the systems engineering community because many of the systems have been simply documented in PowerPoint, if at all. Some of them have been documented in modeling tools. But even if they're in modeling tools, because we're in a transition phase from our model-based systems engineering, from a functional decomposition to an object-oriented decomposition, there's not a lot of consistency in the way those patterns, or the way that those systems are documented. It's going to take a little more time. We have to do a little more research to figure out how in the world to deal with that issue of different methodologies for documenting our systems. I find so that's the methodology wars issue. The other thing that I've found is that everyone that starts talking about patterns, every organization, every company, they want to put their own naming convention. They want to call these different things. And that, in my mind, tends to fragment. We have a problem with the Android community, right? I don't know if you've read about that, but every company does a different variation of Android. So it gets very difficult for app developers to create an app that will run on all the different flavors of Android. Apple, one Apple. You write your application for Apple, it's going to run. You write an application, maybe it'll run on the Galaxy Note, maybe it'll run on the Nexus, but it won't run on one of the other versions. So by coming up with all these different naming conventions and putting their own spin on it, they will fragment a pattern community instead of bringing it together. So I really recommend that if you start doing patterns, that you understand what the existing pattern communities are using and try to fit within those kinds of naming conventions. I have 4 takeaways. The first one is patterns are very natural. I don't understand why we haven't been using it. We have some communities that are using them now. I think systems engineering just hasn't got around to it. I'm hoping to propagate that. They're an enabler to allow your systems engineers and project managers to have the time to focus on what's important. If I had started with that perform command and control pattern, I do have one experience where they shortened their estimated time by 4 months by using that. That gave them 4 more months to spend on the hard problems of the system that they were trying to architect. So it may be an enabler there. They're a learning tool to help share with others. There's some research out there that said, if you do nothing more than document your patterns so that your junior and mid-grade architects can learn, can gather, can learn from your implicit experience that now you've documented and made explicit, they're a valuable training and learning tool, if nothing else. And finally, my get off the stage line is that if you're doing anything with patterns, I want to play. I want to be involved. There's not enough information out there. I was really excited to have the exchange I did with the Consens people today. They showed me some things that they're documenting. I hope that we're going to be able to collaborate a little bit more there so that we can begin or continue to expand this field. With that, as they say, that's my story, and I'm sticking to it. Thank you for your attention.
Consens people, and I do a lot of research also on the solution patterns, and I have plenty of questions. We have not
over
enough time
dinner
here. Yeah, we have some time. Then we have some snacks and some drinks here. We can talk about patterns. But what about the audience? Do you have any questions?
I was missing a concept which was put forward by Christopher Alexander as a very central concept for patterns. It is forces, and in Christopher Alexander's views, the forces are in a certain way, a way to understand what a pattern is all about, because he argues that in most design situations you have conflicting views, forces, interests, impacts, and so on.
Yes, sir.
And a pattern typically resolves these forces in a certain way, so that that is a solution to.
Absolutely, and in fact, if you look up here on the pattern form that I've come up with, I do have.
But shouldn't we talk about more systematically about what forces are and what forces we are talking about in order to find a common pattern language? Because
absolutely.
Otherwise it's just naming conventions.
Yes, sir. No, you're absolutely right. You're absolutely right. I was trying to figure, okay, how do I put a PhD worth of research into a 30-minute talk?
Okay.
So, yeah, you're absolutely correct. And in fact, one of the slides that I skipped over, where was it? It was the one about the light on different angles, different directions. Right there, you see we've actually kind of got a notation that talks about what are the forces that this pattern is trying to balance, because that's what this is all about. What are the things that are acting in multiple directions that cause me to want to reuse this pattern? Okay, so yes, sir, you're absolutely correct.
As a criticist, most of the textbooks which you mentioned just look at the patterns as forms, not at the forces as systematic structures.
You're absolutely correct.
Okay.
Hey, I got to tell you, I'm impressed. I have never had someone in the audience have read Christopher Alexander to know what it is. So kudos to you, sir. That's brilliant. Thank you for the question.
All right. Is there any other questions? Not the case. I have one question just here for the audience, because I think it's very important, because in Paderborn there's a lot of research work done with
the answer is 42.
No, it's not 42. I wanted to know if you have any pattern database already.
I will tell you, there is actually one out there, and it's got almost none in it. It's got my perform command and control. It's got one or two others that people have contributed, but I've almost given up on it, because what I have found as I go to companies, as I do my consulting, as I do my research, there are some companies that are starting to think about this and starting to talk about it, and they may even be beginning to document it, but they don't want to share it. They see it as a competitive advantage. They see it as an enabler to them getting ahead of other companies, and therefore they're unwilling to contribute it to the public domain. I thought it was a great idea to hey, we need to get this going. How can I publish patterns? But the systems engineers and the companies, I mean, everything's IP nowadays, right? Everyone wants to keep their own IP, even within research. We get these lectures about IP, and how does the institution protect their IP? And we've just become consumed by the IP lawyers. So it's a big issue, and I'm not real sure how to overcome that one. I've become very frustrated. I have become very frustrated with that, you know, because that's part of the whole patterns community, is let's share these. Let's figure out how we can improve upon them. So, great question, great question.
If there are any other questions, then thank you again. We also have a little present for our guest speakers. Since I spent the last 2 days with you, I know you're a big fan of German beer, and I cannot give you German beer because I know
I can't take it back on the airplane, right?
But there are some German glasses, and
Oh, very cool.
when you're when you're back in the United States, you have to drink American beer. Then you can think about a good German beer.
Well, thank you very much. So now tomorrow we may have to go buy another suitcase because I came in a very small suitcase and I may not have room to put these in.
No problem.
I will throw underwear away before I throw these away.
Good choice.
Thank you very much.
You're welcome.